All right, so now we're going to move on to our second way of solving a quadratic equation where we cannot factor it, and that is by using the quadratic formula. So the quadratic formula, I would just go ahead and recommend that you memorize this right from the beginning. We've got negative b plus or minus the square root of b squared minus 4ac over 2a. Guess what? It never changes. And again, we're using this to find solutions when factoring just won't work. So let's take a look at an example using the quadratic formula. In question number 1a, we're asked what are the solutions of the equation 2x squared minus x equals 4. So write the original equation, then remember we want to move that 4 over to the left side. Anytime that we have 3 terms in a quadratic equation, we want to have all 3 terms on the same side. Once we've got them in standard form, we can then look at the quadratic formula again and then start plugging in those numbers. Remember that anytime that you substitute a number into an equation, it's a good idea to put that number in parentheses. That way you don't forget to do any operations and you don't end up messing up like a negative where it should have been a positive or a positive where it should have been a negative. So when we substitute our a, b, and c values into the quadratic formula, we end up with negative 1, or negative times negative 1, plus or minus the square root of negative 1 squared minus 4 times 2 times negative 4 over 2 times 2. When we simplify this, we get negative times negative 1 is positive 1. Then inside the radical, negative 1 squared is 1. Then negative 4 times 2 times negative 4 gives us positive 32. And then 2 times 2 in the denominator gives us 4. Simplify that radicand, and you're left with 1 plus or minus the square root of 33 over 4. Now notice that you've got that plus or minus there. That is telling us there are 2 solutions. One of the solutions is 1 plus the square root of 33 over 4. And the other solution is 1 minus the square root of 33 over 4. So when you're presented with a quadratic equation that you're trying to solve, it's a good thing to remember this handy-dandy little list of things that you want to do in order. So check for the GCF first, because that's always going to be the easiest thing to remove. Then if we've got a perfect square trinomial, remember that you'll have 3 terms, and it's going to have a perfect square on both the ax squared and the c term, and then b is going to be equal to 2 squared of ac. Then we've got difference of squares, so you're looking for an equation with 2 terms, and there's got to be a negative in between the 2 terms, and both terms also have to be perfect squares. Then we can also solve using square roots. So if you had something like x squared plus 75 or x squared minus 75 equals 0, then you would just solve for x rather than using any sort of factoring or any other stuff that we've learned so far. Then you've got the normal factoring of a quadratic trinomial. Then you can use either completing the square or the quadratic formula if none of that other stuff works. So that brings us to question number 1b. What are the solutions of the equation x squared plus 6x plus 9 equals 0? Now, what we could do is we could actually go ahead and do the perfect square trinomial on this, but I want to show you what happens when you get one solution as opposed to multiple solutions. So we're going to use the quadratic formula, and you get negative times 6 plus or minus the square root of 6 squared minus 4 times 1 times 9 over 2 times 1. Again, go ahead and simplify this. That gives us negative 6 plus or minus the square root of 36 minus 36 over 2. Now take a look at that radicand. We have 36 minus 36. That's going to give us a radicand of 0. So we know that the square root of 0 is 0. So we end up with negative 6 plus or minus 0 over 2. We can just drop that plus or minus 0 because it doesn't have any effect on us. So you're left with negative 6 over 2, which reduces down to negative 3. For question number 2, we're given a word problem to solve. So the question is, your school's jazz band is selling CDs as a fundraiser. The profit P depends on the amount X of CDs that are sold. The equation P equals negative X squared plus 48X minus 300 models the fundraiser. What is the least you can charge to earn a profit of $200? So what we're looking for here is we're going to be looking for a positive answer. So if we get an equation or a solution that has two answers, we can just toss out the negative answer because we don't need it. Now to set up our equation, what we're going to do is go ahead and rewrite the original equation, and we're going to take that profit of $200 and we're going to substitute that in for P. Now remember, before we do anything else, we want to make sure that we've got everything in standard form. So we want to put that 200 over on the other side. So when we move the 200 over, we're left with 0 equals negative x squared plus 48x minus 500. We can now take the quadratic formula and we can start plugging numbers in. So negative 48 plus or minus the square root of 48 squared minus 4 times negative 1 times negative 500 over 2 times negative 1. Now obviously at this point you're going to need to use a calculator. So we work this out, simplify it down. We get negative 48 plus or minus the square root of 2304 minus 2000 over negative 2. 2304 minus 2000 is going to give us 304 inside that radical. So negative 48 plus or minus the square root of 304 over negative 2. So now plug this into your calculator. Negative 48 plus the square root of 304, and then divide that result by negative 2. Again, we don't need to do the negative part on this of the plus minus because we're only looking for a positive answer. When we plug that into the calculator, we're going to get approximately $15.29. So the least you can charge for each CD and still earn a profit of $200 is going to be $15.29. Now, if you'll think back to a couple of the questions that we've already done, remember that underneath that radical, one time we had a positive and another time we had a 0. Well, that tells us a lot. Underneath that radical, the b squared minus 4ac, that is what we call the discriminant. And the discriminant lets us know how many solutions we're going to have for each problem. So if the discriminant is positive, there's always going to be 2 solutions to the problem. If the discriminant is 0, there's going to be 1 solution. And if the discriminant is negative, we're not going to have any real solutions. Instead, we're going to have 2 imaginary solutions. Now, we haven't covered imaginary numbers yet, but we will get to those later on. What do those solutions look like when we put them on a graph? If we have 1 solution, then our parabola is going to touch the x-axis in exactly 1 place. If we have 2 positives, or if we have 2 real solutions, then our parabola is going to touch the x-axis in 2 places. Then if we have no real solutions or imaginary solutions, then that means that our parabola is never going to cross the x-axis. So here in problem number 3, we're being asked to use the discriminant to find how many real number solutions does the equation negative 2x squared minus 3x plus 5 equals 0 have. So again, write out the original equation, and then we're going to look at our discriminant, which is b squared minus 4ac. Plug in the values for the discriminant. So we get negative 3 squared minus 4 times negative 2 times 5. When we simplify that down, we get 9 plus 40, which means that we get a solution of 49. What this tells us is that there are going to be 2 real number solutions for this particular problem, which means that when we graph this, our graph is going to touch the x-axis in 2 different spots.